They say that only two things are certain in life: death and taxes. But I'd like to add a third to the list: chaos. If anything in your life ever goes wrong, then you can probably blame chaos. And no, this isn't some self-help guru speaking. It's scientists. The universe itself seems to have a tendency to go off the rails occasionally. And with each passing day, we discover more and more examples of how unexpectedly it can do so. But what exactly is chaos? How does it happen? And why should you care? Well, because understanding chaos not only helps us predict all the ways things can go wrong, it also teaches us some valuable lessons about risk, uncertainty, and even happiness. So let's explore the surprising ways that things can go wrong. Let's start out by talking about the most famous example of chaos: the butterfly effect. The idea was first proposed by meteorologist Edward Lorenz in 1969. He noticed that when he rounded off the decimal point in a number used in his weather simulations from 0.3 to 0.0, the results were wildly different. Instead of getting a gradual change in the forecast, the new simulation showed a completely different and incorrect weather pattern. Basically, a tiny change in one place led to huge differences down the line. Since then, we've learnt that this sensitivity to initial conditions is a general property of chaotic systems. They're highly dependent on their starting points. And while we can never know the exact initial state of a system, the tiniest error will eventually add up to big differences. And while it might seem obvious why rounding off a number would affect a weather simulation, it turns out that a wide range of systems are chaotic under the right circumstances. For example, if you've ever driven really far in a car, you know that sometimes your GPS will lead you into traffic, forcing you to make a detour. Sometimes it'll be a small detour. At other times, it'll feel like you re-driving around the entire city for no reason. It's actually the same phenomenon at play. In both cases, your route has a lot of variables that are impossible to account for, like the number of cars on the road, the likelihood of someone cutting across multiple lanes, or even the possibility of an accident. These variables interact with each other in complex ways to create outcomes that are nearly impossible to predict. So, just like the weather, there are infinitely many possible paths that you could take, but only one that will be the fastest. And you don't need to get in your car to see this in action either. Even playing a video game is full of surprises, thanks to chaos. Remember that time you got ganked by an enemy team, despite having a massive advantage? Or maybe that's just me. Either way, it's an example of how chaos makes even deterministic systems unpredictable. You see, a deterministic system is one that follows a set of rules or laws. Like in chess, if you know the position of all the pieces and the rules of the game, you can calculate the outcome of every possible move indefinitely into the future. However, this is rarely the case in real life. Because of chaos, small changes can make a big difference. A tiny variation in the position of a falling domino can prevent it from hitting the next one. And that's enough to cause a chain reaction that doesn't fall in the way that you expect. This is why no two games are ever the same. Even when they're played by the same person on the same difficulty level, a little chaos goes a long way. It's not just complicated systems that exhibit chaotic behavior. It can happen even with simple ones. Take the double pendulum, for instance. It's just two connected pendulums swinging back and forth. Despite its apparent simplicity, it's chaotic under certain conditions. When those conditions are met, small differences in the length of the pendulums, or the angle that they're swinging at, can cause them to diverge over time until they look completely different. At first glance, It looks like nothing could possibly cause such drastic differences. But chaos shows us that even something as basic as a double pendulum can surprise us. Chaos can have serious implications, too. That's why meteorologists study it so much. They want to understand how a tiny inaccuracy in temperature readings from Tokyo could lead to a major storm in Florida. But chaos isn't just a force of nature. It can be caused by human actions, too. Take the collapse of the Tacoma Narrows Bridge. In 1940, this suspension bridge was destroyed by wind, even though it was designed to withstand much stronger winds. You see, the engineers didn't know that the wind conditions around the bridge would cause the structure to enter a chaotic state. This made the bridge vibrate violently until it finally collapsed. It wasn't until decades later that scientists understood the role that chaos played in the disaster. But they weren't able to predict it in advance, because chaos is unpredictable by its very nature. Of course, it's important to note that chaos isn't the same thing as randomness. Randomness implies an element of chance or probability, whereas chaos is deterministic. In a random system, each possible outcome is equally likely to occur. But in a chaotic system, there's a preferred way that things unfold. It's just incredibly difficult to determine what that unfolding will be in advance. In fact, that's the main difference between a chaotic system and a non-chaotic one. Chaotic systems are extremely sensitive to their initial conditions, whereas non-chaotic systems aren't. If you were to repeat the initial conditions of a non-chaotic system over and over again, you'd get the same result every time. But a chaotic system will always produce a different outcome, no matter how similar the starting points are. So if you're trying to figure out which kind of system you're dealing with, just ask yourself, does the outcome depend on where it starts? If the answer is yes, then you're dealing with chaos. But why should you care about chaos? After all, it's not like we can control it, right? Wrong. Not only can we control it, but we can also harness it to our advantage. Take the double pendulum again. By changing its initial conditions, we can influence where it ends up. Similarly, we can use chaos to stabilize a system that's too chaotic to be useful. For example, Lorenz wondered whether it was possible to control the weather by seeding clouds with silver iodide, which would encourage them to produce rain or snow. While this technique is still being debated by scientists today, it has been used in many parts of the world to try and control the weather. So, if you want to make a career out of controlling chaos, you should consider becoming a cloud seeder. There are plenty of jobs available, especially in places like Florida, where the weather can be, well, chaotic. Another way that we deal with chaos is by accepting it. We know that we can't predict the future perfectly, so instead of trying to, we focus on what we can control. This is why mindfulness and acceptance are so popular these days. By focusing on the present moment, we can stop worrying about all the things that might go wrong in the future. So if you're feeling anxious, just remember that chaos is always with us, even if we can't see it. And while it can sometimes cause problems, it's also what makes life interesting. Speaking of things that can go wrong, if you've ever tried to learn a new language, you know that it's not always easy. Sometimes it feels like no matter how hard you try, there are just some things that you can't seem to wrap your mind around. But what if there was a better way to learn a new language? If you enjoyed this video, then you will love our new channel where we've collected all of our favorite stories about science and technology. Every week we'll hand-pick videos for you to watch. Thanks for watching.